So we're looking at geometric representations of complex sets of numbers which provide multiple solutions to situations we're after. What I'm going to do here, I've got a couple of questions for you. I want you to read the questions, pause the video, have a crack at them, and then come back and look at the work solutions that I'm going to present here. So here you go. So 3 sets of questions there. I want you to get the solution set of each equation below. Remember the format and the type of question that you should get and the type of set of solutions that should come up. If you need to refresh your memory, go back and look at the theory video, and that'll at least give you an idea of if you're on the right track. So pause the video and have a go. So the first one was modulus of z plus 2 equals 5. So first thing, remember, all we do is substituting for z to begin with. So I'm after the modulus of x plus iy plus 2 equals 5. Always remember our standard substitution is z equals x plus iy. Stick to that no matter what at this stage until it tells you otherwise. Then group the real and imaginary parts together. So I've got modulus of x plus 2, then it's plus iy, so that's my imaginary part, and that equals 5. We know what the modulus represents, so we calculate it from here. So we've got x plus 2 squared plus y squared. Now remember, it's the square root of all this, so what I'm going to do is I'm going to get rid of the square root by squaring this side, and that's going to equal 25. If you still want to take the extra line, write it out. So if you still want to take that extra line and put in the square root in and saying, right, I'm just remembering it's the square root of x plus 2 squared plus y squared equals 5, and then squaring it to get there, do it. Take your time if you need to. Bottom line is, you need to get to here and then be able to interpret it. Now this format of the equation tells me that it's quite simply a circle, and we have to read off the 2 key bits of information about the circle: the radius and the centre. Now the radius for this one, r squared is 25, so I know the radius is equal to 5, and my centre, comes from these parts here. My centre for this one is -2, 0. So that there represents a circle, radius 5, centre at -2, 0. So if I was to do a wee sketch of it, I'd end up with a circle that looks something like that, hopefully slightly better drawn. There's my centre there, and that's the radius. So anything on this circle provides me with a complex number in the set that I've got that has a solution to this equation here. The second question was modulus of z minus 2i equals 4, and I want again the set of complex numbers that will satisfy this equation. Same sort of steps as we did before, substituting for z to begin with, group the parts together, see what I get at the end. So if I substitute in for z, I get x plus iy, take away 2i, equals 4. Group the real and imaginary parts on the left hand side together, and I get x plus I bracket y minus 2 equals 4, and then calculate my modulus. So I've got x squared plus y minus 2 squared. Again, I know it's over a square root here, so I'm going to just shift it across by squaring this side, and that equals 16. So now the interpretive part of it, what does it mean? Well, it tells me it's a circle. So again, the key bits of information, I need to know what my radius is, and I need to know what my centre is. So looking at this, the radius, square root of this side, it's 4, and my centre, looking at the left hand side, is given by 0, 2. So that there then tells me it's a circle with a radius of 4 and a centre at 0, 2. So if I were to sketch that, it would look something along the lines, centre at 0, 2, so my centre would be there, circle of radius 4, it would look something along the lines of that. So there's the radius of the circle, r equals 4. So any number on this circle, any complex number on that circle, would give me a solution to this equation here. So I've got all my set of numbers for that. Third question was modulus of z plus 2i equals the modulus of z plus 3. Now again, this is the one we have to think, what kind of solution should I get? And then work it through to get, hopefully, the solution we're after. This sort of one, remember, gave me a straight line equation because it was the perpendicular bisector of the straight line between the 2 points it would represent. So, same set of steps, keep it as standard, substituting for z, group real and imaginary, calculate our modulus, see what we get from there. So left hand side, we become modulus of x plus iy plus 2i equals the modulus of x plus iy plus 3. Group the real and imaginary on both sides, and I get the modulus of x plus I bracket y plus 2 on this side equals the modulus of x plus 3 plus iy on this side. So there you go, I've got my two sides of the equation. Now I take the modulus of both. Now remember, they both have a square root, so let's ignore that, and what we'll end up is we'll end up getting x squared plus the y plus 2 all squared on this side equals x plus 3 squared plus y squared. Now again, you're thinking equation of a straight line, but you've got squared variables there. Remember, they should cancel. Multiply out the brackets and let's see that they do. So multiplying it on this side out, x squared plus y squared plus 4y plus 4, that's going to equal x squared plus y squared plus 6x plus 9. So yeah, the x squared and the y squared will cancel from both sides, and I'm left with just x's, y's and a constant. So let's stick it all together on the same side. What I'll end up with then is I get 6x, take away 4y plus 5 equals 0. So that's the equation of my line there. I could stick it all on the other side and end up with 4y minus 6x minus 5 equals 0 as well. Either variation is fine. It may ask you for a format, but just go with whatever you feel is best in terms of what you understand better if it doesn't. I personally would probably stick with the top one. So there you go. That's how we'd approach these questions. Just remember those standard set of steps. Substitute in the standard format, x plus iy for z, group real and imaginary, figure out your modulus, and then equate and figure out what kind of set of numbers are you going to get to solve these. Make sure you cover everything, whether it's inside a circle, outside a circle, or your perpendicular bisector straight line, like in this final example here.